Okay, so let's quickly go over the solution to the second unit hydrograph problem, which the practice problem, and it differs from the first in a couple of ways. One is that we are now using metric units, so precipitation is in millimeters, and we're going to be deriving a unit hydrograph in terms of centimeter, 1 centimeter of total excess precipitation over the watershed. The second difference is that this is now a 2-hour unit hydrograph because the precipitation event we're going to use to model the unit hydrograph lasts 2 hours long, as you can see here in in columns A and B. So a couple things we need to do. We'll need to know the area of the watershed. It's given in kilometers. We'll need to calculate that in meters squared. And for that, I'm just going to use the convert function in Excel. So from here on out, the steps are going to be very similar to what we did the first time. So the first thing we're going to do is calculate the volume of precipitation that occurred within each hour. So this is going to be my quick flow in terms of cubic meters now, right? I'm going to take the value of the hydrograph for that hour, which will be D3, and I'm going to multiply it by the number of seconds in an hour because this is in terms of cubic meters per second. And then I'm going to copy that all the way down, and that will give me my total volume of water that flows, quick flow that flows through past the observation point in the outlet stream per hour. And now I'm just simply going to sum this. This is the total then quick flow or event flow or storm flow that comes from that precipitation event. That will equal the sum of everything in column E. So E3 one trick here is just to give it a really large number because I know there's nothing beneath my data, and that way I don't have to go down and look at where it ends. So there we go. That's the total volume then of water in cubic meters that is due to the quick flow, the precipitation event. And I want to convert that now to a depth. So this is now the quick flow in terms of depth. In terms of meters, and remember I get that by dividing the total volume by the area of the watershed. Since the total volume is in cubic meters, the area of the watershed in cell B16 is in square meters. That's just what I want, and it will give me a total depth of quick flow in meters. So I'm going to take the value in F3 and divide it by the value in B16. My volume divided by my area, I get a depth of 0.0148 meters. And remember, I'm going to eventually want this in centimeters. So I'm going to want this total depth in centimeters because that's the unit I want. I want to determine the unit hydrograph so that this number would turn out to be 1 for my unit hydrograph. So I'm going to take, if that thing is in meters, I can just use the convert function from G3 in meters to centimeters. And there we go. So it's a little less than 1.5 centimeters of total depth of quick flow comes from this precipitation event. Now let's compute the total amount of total precipitation that came from this event in centimeters. So that will just be the sum of all these numbers here, but that's in millimeters. So to get centimeters, I'm going to need to divide that by 10, since there are 10 millimeters per centimeter. That might be something you know. So I'm just going to take this sum of all of these, and I'm going to divide by 10, and I get 2.5 total centimeters of precipitation. Remember that the event flow, this number here in column A, in cell H3, this must also be equal to the total amount depth of effective precipitation. So I can really quickly calculate here my ratio of effective precipitation to total precipitation. That is going to be the effective precipitation in cell H3 divided by the total precipitation in I3. Oops, I think I need an equal sign there. So equals H3 divided by I3, and I get something like a little less than 60% of the total precipitation turns out to be effective precipitation. So it doesn't infiltrate, it goes quickly into the stream and then rushes down to the mainstream, and that's what I'm measuring at the storm hydrograph. Okay, we are almost done here now. Now, in this particular example, I haven't actually set up the unit hydrograph. I want you to do that, so let's talk about how we would do that. So the unit hydrograph, this is going to be a 2 hour, it's going to be a 2 hour unit hydrograph, right? Let's try to, how do I do that here? How do I do that? We want to merge and, yeah, stop. There we go. Okay, it's a 2 hour unit hydrograph, and we're going to be plotting the time in hours, right? And time in hours versus the quick flow discharge in cubic meters per second for the unit hydrograph. So remember, that's going to look like my storm hydrograph, except I have to scale it by the actual amount of storm discharge depth that this storm produced. It produced 1.5 centimeters, 1.48 centimeters. The unit hydrograph should only produce 1. That's the definition of the unit hydrograph. So I'm going to have to take my discharges in column D and divide them, each one of them, by this factor of 1.48. So my time here, I'm going to have to let this go up. And the trick here, once I start a sequence here, I can just highlight it, grab the lower right corner, and then just drag it, and that sequence will be repeated. And I'll go down to the bottom here. Probably all I'm going to need, right? Okay. And now, again, I'm going to take the discharge that I observed in cell D3, and I have to scale this by dividing by the value in cell H3. So $H, $3, because it's an absolute cell reference. And there we go. Actually, let's just copy this down. This is going to be my unit hydrograph now. There we go. And I will make this look a little nicer by just making this look like that. There we go. All right. So in the other one, I gave this certain colors to make it clear that this was my unit hydrograph. This is what my hard work determined at the end of the first part of the problem. And for the second part of the problem, I'm going to take this unit hydrograph, this 2 hour unit hydrograph, and I'm going to apply it to a specific stream.